This is the Unit 12 Test Study Guide, Part 2. Topic 1 is graphing trig functions. So we had 6 different functions. So the first set is just this. You've got the A and the B, the amplitude, the period. We're not doing any phase shift or vertical shift for the first set, just kind of warming up with these. So the amplitude is the absolute value of A. So whatever value is out front, kind of attached to everything else. And then the period, we've got 2 different versions. So for sine and cosine, and then their reciprocals, cosecant and secant. The period is 2 pi divided by b, so like this value that's attached to the theta, and then tangent and its reciprocal, the period is just pi divided by b. All right, so slightly different. Tangent repeats itself more frequently than sine and cosine do. So first one, we've got 3 times the sine of theta. So the amplitude is really easy to spot. It's always right in front of whatever one of these 6 trig functions. So the amplitude here is 3. The period is 2 pi divided by 1, so that's 2 pi. All right, so remember we've got this sort of 5-point pattern that your sine function takes on. So you want to do the start to the finish first. So the sine function starts at the origin if there's no phase shift or vertical shift, and there isn't yet. And then its period is 2 pi. So it starts on the x-axis, it ends at the x-axis, and then also halfway through its cycle, it's on the x-axis as well. So these are points 1, 3, and 5. Now points 2 and 4, it goes to the high point and to the low point. The amplitude is going to affect how high, so the high point is up at 3, the low point is down at -3. So that's one cycle, and then you just reverse that cycle and work its way back through, just reversing the exact process that you just did. So that's another cycle. So we're just rolling through this sine graph. Okay, next one, 5 times the cosine of 1/2 theta. So the amplitude is the value out front, which is 5. Period is 2 pi divided by 1/2, or 2 pi times 2, which is 4 pi. All right, so the cosine starts on the y-axis. It starts at its high point. So its high point would be up at a +5. And then it ends its graph back at the high point. It would be ending its cycle all the way over here at 4 pi. We don't go all the way to 4 pi. So as far as we get is this 2 pi. So halfway through the cosine cycle, remember it's down at its low point. So halfway through would be down at its low point. So really we only get to see half of the cosine cycle on this side. Point 2 would be a quarter of the way through. So halfway between these 2 points, it'd be right on the axis. And then you just reverse this off to the other side. So reverse that point, reverse this point. And so you get like, this is half of a cosine cycle, finishing one, and then we start the other half of another cosine cycle. So they would start going back up after this. Number 3, we've got a tangent function. The amplitude, remember, is always undefined. This is really tempting to write down, but it's not actually an amplitude, it's just a vertical compression, and you'll see how that affects our graph. We say amplitude is undefined because we've got a whole bunch of vertical asymptotes. And the period is just pi for tangent divided by 2. So pi over 2 is our period. All right, so what that's going to do, it's going to make things happen twice as fast. All right, so normally we would have this point going right through the origin, and then the next point usually wouldn't happen until pi, and then 2 pi, but we're cutting the period in half. So instead of waiting all the way till pi, it happens again at pi over 2, and so they happen every pi over 2 instead of every pi, because it's like doubling the speed of the cycles that it's going through. So repeat, reverse over on the other side here. All right, and then normally it's the weird rule for vertical asymptotes. It's every odd multiple of pi divided by 2 times this value. So it's every odd multiple of pi over 4. So 1 pi over 4, 3 pi over 4, etc. So here's 1 pi over 4. 3 pi over 4. So really it just ends up being all the spots in between these x-asymptotes are your vertical, your x-intercepts, are your vertical asymptotes. So we got a whole whole bunch of these. There are technically an infinite number, you remember. All right, so lots of asymptotes. Now here's what the vertical compression is going to do, 1/4. Normally, let's take this one for instance, it goes up a unit. Well, normally it goes over 1 and up 1, but since we cut everything in half, it's only going over a half and up 1. But instead of going up 1, we're only going to go up 1/4. Okay, so it's going to go over half and up 1/4 of a unit, and then it reverses that. All right, so you can see it gets really like flat in here and then back up the other way. Now, since I have so many of these to graph, we have, down 1/2 and 1/4, so halfway to the left and right, and then just 1/4 of the way up and down. So a whole bunch of those, just perfectly repeating that pattern. Just do your best to make them all similar, and then these are just this repeating cycle, just over and over again, using those points and using the vertical asymptotes as a guide. The important part is that the points and the asymptotes and all of that stuff is accurate. If something looks a little messed up in the graph, that's going to be fine. All right, cosecant graph. The amplitude, again, is undefined because you've got an infinite number of vertical asymptotes. The period is 2 pi divided by b, so 2 pi divided by 1. So this one, we've got this sort of an amplitude. You'll see what it looks like when we go and do cosecant. So cosecant has a normal period, so it's kind of just like the sine function here, but it's the reciprocal. So every time that sine has a value of 0, the reciprocal of 0 would be undefined. So every spot that we normally have an x-intercept, this graph will have a dotted line of vertical asymptotes. So 0, and then you can see it's every multiple of pi. And since the period doesn't change, the frequency of these asymptotes doesn't change, excuse me. All right, so we've got asymptotes right there. And then this, think of what the amplitude on the sine graph would look like, and then remember that that point gets flipped upside down. Okay, so here we're going, instead of up to a height of 1 on these points right here, so like when the sine graph hits its high point would only be here at 1/2. And then sine would be 0, and then sine would be at its low point, and then you just repeat that. So if we work backwards and just mirror that pattern, it looks like this. Okay, so you've got these just like almost parabolic type of shapes. They're not quite what parabolas usually look like on the top. They usually get a little flatter than parabolas do, but it's a similar sort of idea just to keep in mind. All right, a secant graph for number 5. The amplitude is still undefined because we've got a bunch of asymptotes. The period is 2 pi divided by 3/2. So the 2's ends up canceling, and we get 3 pi as the period. All right, so remember, secant is the reciprocal of cosine. So we start kind of going through just like the pattern of cosine. So cosine starts up at its high point. And so this does the same thing. So starting up at its high point would have a value right here of 2. And then the end of the cycle, so the end of the cycle would be 3 pi. This is the part that gets a little bit tricky. When you divide it into its 4 intervals, we end up going by 3 pi over 4. So at point 2, when the cosine graph would be in the x-intercepts, like that's point 2, and that's 1/4 of the way through the cycle. 1/4 of the way through the cycle, this would have a vertical asymptote because cosine would have an x-intercept. So 1/4 of the way through is at 3 pi over 4, so that's right here. Halfway through the cycle would be 6 pi over 4, which is 3 pi over 2. So cosine would be at its low point, and the low point would be 2 units down because of the amplitude of the cosine graph. And then another 3 pi over 4, so this is all just going 3 units. So 3 units to this point, 3 units to this point. 3 units would end up at another horizontal asymptote. Okay, so then we can just kind of mirror that back the other way. So 3 more units would be a horizontal asymptote. 3 more units would be a low point. And 3 more units would be a horizontal asymptote. So we've got very similar to the cosecant, just these sort of parabola shapes, using the asymptotes and using these points as your guide to how low and how wide these pieces are going to get. All right, and a cotangent graph. Amplitude, undefined. Period is pi divided by 1/3, or pi times 3, which is another 3 pi, like we were dealing with here. All right, so let's go with these. So 3 pi is how wide this graph is going to get, and then the amplitude is actually only 1/2. Okay, so think what a tangent graph normally looks like, right? So when a tangent graph has an x-intercept, the cotangent graph is going to have this dotted line right here, right? So now this one's actually shortened. Tangent, normally it has an intercept at 0, and then its next intercept wouldn't be until pi, right? It's the value of the period apart. So if this is at 0, the next one wouldn't happen until 3 pi. So you don't see another asymptote at all. So the next one would be all the way over here at 3 pi. The next one would be all the way over here at -3 pi. All right, so then the next thing, where a tangent normally has a vertical asymptote, the reciprocal would have an x-intercept. So they're kind of trading places. So it would be halfway through the value of the cycle. So halfway through 3 pi would be 3 pi over 2. All right, so 3 pi over 2, we have an x-intercept, and then you can mirror that back on the other side. So basically what this shape looks like, the cosine just kind of reverses it. So it starts upper left, ends lower right, which is opposite of this one. So we would start upper left, curve our way through here. What this is going to do, the 1/2, go halfway between these points. So that would be at 3 pi over 2, and it's only going to be half a unit up. All right, so it curves down along through here, and then here would be half a unit down, and it just like curves back that way. Eventually it would hit another vertical asymptote. All right, and then reverse this back. So halfway through would be half a unit down, halfway through would be half a unit up. So this kind of glide along here so you can see what the second half of this would look like. And then it curves its way up and starts headed back towards what would be another vertical asymptote. So that one got really stretched out and made it look pretty weird.